Hello everyone. In this video I am solving the first question of exercise 19.1. Express the following in the modulus amplitude form. First question is 1 plus sin alpha plus I cos alpha. So we need to write 1 plus sin alpha plus I cos alpha in modulus amplitude form. That means z is equal to r e raised to I theta. The modulus mod z is equal to modulus of r e raised to I theta. We can write e raised to I theta as cos theta plus I sin theta. So modulus of e raised to I theta is square root of, modulus is defined as the square root of real part, sum of squares of real part and imaginary part. That means cos square theta plus sin square theta. So this is square root cos square theta plus sin square theta is 1, square root 1 is 1. So this is mod z is equal to modulus of r itself. So r is, if z is equal to x plus iy, r is modulus of z, that means square root of x square plus y square. So here we need to find r and the argument theta. So r is simply the square root of real part square plus imaginary part square. That is 1 plus sin alpha whole square plus cos square alpha. And that is equal to 1 plus sin alpha whole square is 1 plus sin square alpha plus 2 sin alpha and plus cos square alpha. We know that cos square alpha plus sin square alpha is 1 and this 1 plus 1 is 2. Now I'll take 2 outside. So we get 1 plus sin alpha. So this is root 2 root 1 plus sin alpha. And the angle is defined as theta is equal to tan inverse y by x. That means z is equal to r e raised to theta. In polar form r is x is r cos theta and y is r sin theta. This we get in Aragon plane if x is equal to r cos theta. R is the magnitude and theta is argument. Y is equal to r sin theta. Now y by x we get tan theta. So theta is tan inverse y by x. So the angle theta is tan inverse y by x. So here y is the imaginary part cos alpha and x is the real part 1 plus sin alpha. So this is the angle. So we can write this as z is equal to r e raised to I theta. That is z is equal to, that means this 1 plus sin alpha plus I cos alpha, that is equal to r is root 2 into 1 plus sin alpha e raised to I, theta is tan inverse cos alpha divided by 1 plus sin alpha. So this is the modulus amplitude form of 1 plus sin alpha plus I cos alpha. So next question is 1 by 2 plus I all square minus 1 by 2 minus I all square is this. So second question. So this is 2 plus I all square. We can write it as 1 by 2 plus I all square is 2 square 4 plus I square is minus 1 plus 2 into 2i is 4i minus 1 by 2 minus I whole square is 2 square is 4 plus I square is minus 1 minus 2 into 2i is 4i. So this is 1 plus 1 by 3 plus 4i minus 1 by 3 minus 4i. So we can cross multiply this. This is 3 minus 4i minus 3 plus 4i, here is minus 3 minus 4i divided by 3 plus 4i into 3 minus 4i. 3 plus 4i into 3 minus 4i is a plus ib into a minus ib. It's clearly a square plus b square. A plus b into a minus b is a square minus b square. So this is 3 minus 3 minus 4i is minus 8i. This is a square plus b square. That means 3 square 9 plus b is 4, 16. Or a plus b into a minus b is a square minus b square. Minus 4i all square is 4 plus 4 square. That is 16. So this is minus 8i divided by 25. So this complex number becomes minus 8i by 25. That is, we can write it in the form x plus iy, that is minus 8i by 25 is 0 plus I into minus 8 by 25. This is x plus iy form. Now in modulus amplitude form, we can write this z equal to r e raised to I theta, or we can write z is equal to r cos theta plus I sin theta. Here what is r? R is equal to square root of x square plus y square. That means x square 0 square plus minus 8 by 25 whole square. This is minus 8 by 25 whole square root. Square root is 8 by 25 itself. Now angle theta. Now here we cannot use tan inverse y by x since x is equal to 0. So in a Aragon plane, we know that this is I minus 8 by 25. Only the imaginary part is here. So this is in this line, y-axis, that is imaginary axis, minus 8 by 25 is somewhere here. So if this is the point minus 8 by 25 or any point in this axis, negative y-axis or imaginary axis. So the angle from 0 to here is, this is the angle. This is clockwise, this is angle pi by 2 or 90 degree, and this is clockwise. Clockwise measurement is negative. So this angle is minus pi by 2. This angle is pi by 2 and anti-clockwise. Clockwise is negative. So minus pi by 2 is the angle. So we can write it as z is equal to, or this z here we get minus 8i by 25 equal to r. R is 8 by 25 e raised to I theta. Theta is minus pi by 2, or we can write it as 8 by 25 cos minus pi by 2 plus I sin minus pi by 2. Cos minus pi by 2 is 0 and sin minus pi by 2 is minus 1. So this is minus 8i by 25 itself. So this is the modulus amplitude form of the complex number 1 by 2 plus I square minus 1 by 2 minus I whole square.